Let me go ahead and share my screen. And if I get interrupted, it's because I have to admit more and more people. So hopefully you can see my screen. This is our starting topology. And I actually have a PowerPoint for us too. Oh, this is the PowerPoint. I have can everyone see the packet tracer starting topology and the starting topology and my PowerPoint right here? Can you see both?
Yes.
You can see both? Yes. Okay. So we're going to talk about final WAN routing concepts before we get into layer 2 because it occurred to me yesterday that I forgot a couple of things. So first of all, let's talk about this topology. This is a very popular topology in enterprise networking. And let me just go through here. Okay, so here, let me just the typical enterprise setup is you have what we call the local edge router right here. So we have the enterprise environment below the edge router. So the enterprise environment is going to be a switch. Hold on just a second. Okay. This layer 2, the edge router right here, and let me just say it's going to the edge router is referred to as an edge router because it's going to be the dividing line between the LAN and the overarching network that is beyond. So that's WAN 1, and then we have this other network right here that is key to things, to the core operations of the clients. So beyond this layer 2 switch, we have the departments here that do the core work. So in this department, we might have operations. Here we might have assembly. Here we might have admins. Okay, like marketing, like everyone that is important but that doesn't do the core work. Things like marketing, things like executives, the C-level suites and all that. So that's under here. Now, as each of these, and then in this layer 2 network, you're going to get a lot of intervening switches and everything. So it's just a big conglomeration. Okay? It's almost like just the details of this is really irrelevant. Just know that this is like where the clients are. So this is the edge router. But here is what I want to say. Now the edge router is going to divvy up the outward locations to a couple places. It can go, like, let's say right, and it could go left. Now here, this cloud, we could call this the big I. Okay, we'll just call it the big I. So that's going to be your internet. Here is going to be lower I, or smaller case I. Okay, this is generally going to be referred to as your local data storage or your local data base or your local data center. So in this case, you could have all the pertinent files, okay, that everyone in this local area network is going to use on a daily basis. That's on the right-hand side. Okay, so everything that it needs, local data storage and local data center. So, like for example, you have this client right here, he's working on the Smith file. Now, when I say that this client, I call them assembly, operations, and executive. This could be a play place for kids. This could be, an engineering, like this could be maybe a place where they do civil engineering, like drawing the lines for construction, construction lines, boundaries for construction sites. It could be a food service, cafeteria. It could be anything. I'm just saying that if this client needs to reference the company's local storage, like if this guy is working on an engineering project and some of the files he needs are here, he's going to make a request and it's going to go out this way. However, and that's the small I. So what I mean by small I, okay, what I really mean is internet with the small I. And we can just, for example, underline it. Here is the internet with the capital I. So what we're saying is that if this, so like if this computer, if the request is to the local storage center, it's going to go to the right. But if he wants to go to, Facebook, Amazon, or anything else, or let's say he needs to get a security update from Google, it's going to go out this way. Okay, so let me ask you, here's the question of the day. Now, we'll call this computer A. And here's the question. If computer A wants let's say he wants to archive his past projects, with the product ABC archival service, which way will the request go to? Left or right?
It'll go right.
Well, I said this is local storage, local data center, and it was only for core things that he's currently working on. And the reason why, this is a trick question, so don't kill yourself for not getting it right. So a lot of times, third parties will archive your records for you. But when they do that, yes, there are times when they will come in and provide you a very large a hard drive or storage solution, and then you can actively archive your things locally, on-prem, as they say. And so, just so you know, this is on-prem. Let me just put this right here. On-prem, meaning on premises. This is off-prem. Oof-prem. Off-prem. So computer A wants to archive his past projects with ABC archival service. So that implies it's not your company. So if it's not your company, it's off premises. Okay, it's off premises. That means you have to go through the internet. Okay, so a lot of people, this is what I want to just tell you, that I want to impress upon you, that believe it or not, right now, and I don't know if you've ever heard of the 80-20 rule in business. So, for example, Typical retail store, 80% of the profit comes from the selling of only 20% of the goods. Okay, that's the 80-20 rule as applied to business. Now, when it comes to networking, the rule used to be that the 80-20 rule was that 80% of all networking requests were held within the local area network, were held on-prem. Okay? And if you wanted to go off premises, like go to the internet, that was only for certain things, like archival services. It used to be that the internet, there's no way that you, as a worker at Stellantis, should ever really get access to the internet. Okay? But that's not very realistic, because if you want to pay somebody so much money a year, you want him to be happy, you want him to be productive, and you can't be happy and productive if, let's say, you have a child and you're not able to, like, maybe you want to message him over Facebook or something like that. So, and the other thing about the internet is sometimes you do need things from the Wild West. Even though the internet's the Wild West, you do need some things from the internet. Like there are companies that archive, but there are sometimes many things you need. Like if you're a programmer, you're going to be going to Google all day because, Stack Overflow, Copilot, Chat GPT, those you will need access to all of that stuff to do your job when you get to there. You're still going to be doing those things. Okay? So yeah, there's no shame in integrating the internet into your actual network. And so the way this works, the way this actually works is that most enterprises are built such that you have your edge router right here, and then you have your network underneath, your layer 2 switch. I'll just do this and to simulate networks. But if you go out of the network, one leg it gets you to your internal network for your data stores. The other leg gives you access to the internet. Okay? And some of you are like, well, wait a second, doesn't that violate security? Well, the problem is, the opportunity is because you are integrating the internet into your network, meaning you're defining which way it goes out, which way it forwards out. Here, you can set up controls here that controls what gets downloaded. So some firewalls are able to allow you to go to Amazon, but they block all the ads because the ads take up too much bandwidth. Okay, you can go to some firewalls allow you to go to Facebook, but you can't instant message anyone. So if your child is having a soccer game and it's 2:00 in the afternoon and you can't be at the soccer game, if the soccer game is simulcast on Facebook, then you can still watch it, but you can't send out personal messages because it takes up too much bandwidth. Okay, that's what and I just wanted to keep this in mind. This is an actual enterprise level topology.
So, Professor, I got a question.
Yes.
So, are you saying like the local area network, they have their own router, and then it's a router for the internet?
Yes. It doesn't have. It can be like that, but it doesn't have to be like that. You usually with traditional enterprise networks, you have an edge router, and then it matches up with another router that routes the direction of your of your request, but it doesn't have to be that way. Sometimes the edge router will take you directly to the data store and then directly to the internet. But it all depends on how it's set up.
Okay.
All right, now let's go to this in Packet Tracer. Okay, we have this set up right here. And the other thing I want to introduce to you is the notion of a multi-layer switch right here, and we'll get to that in just a second. But here we're doing the starting topology, and I just wanted to emphasize this multi-layer switch right here. Now, let me take you to the actual packet tracer right here, and let me just show you what it looks like. It looks like this, and it's covered up because of these interface labels that packet tracer does. But this is what a multi-layer switch looks like. Okay, now multi-layer switch details. This makes me, let me just do that because it looks better. It has a capability or capacity to forward based on layer 3. So this is the very familiar layer 2 switch icon right here that I've drawn more times than I'd like to admit. Now, a layer 2 switch, we have computer A, computer B, and computer C. Now, the advantage of a layer 2 switch over and above a hub is that when layer 2 sends a request to computer B, as long as everything is in convergence, as long as the MAC address table is filled, computer C will not be receiving the request that was meant for B because of the fact that a layer 2 switch is a multi-port bridge, and the bridge has a capacity to forward and filter based on MAC address because of ARP tables, because of the MAC address tables. Okay, but the main thing I want everyone to understand about a layer 2 switch is that it forwards based on layer 2 only. Layer 2 and layer 2 only. That's it. It doesn't really comprehend layer 3. There is no encapsulation from layer 3 to layer 2 as A messages B. Okay? There's a reason why, and the advantage that layer 2 switches have over and above putting a bunch of bridges is that, yes, bridges did forward off of layer 2 because of software, but these switches have advanced hardware that allows the switch to forward layer 2 lightning speed at hardware speeds at about the same type of speeds as your graphics card, because a switch is like an appliance. It's not really a piece of hardware. It's like an appliance. It just does one thing. It's like your microwave or your oven. That's why generally they don't break down, because they do one thing. Is there a computer chip in your microwave? Yes. Are there computer chips in your washing machine and dryer nowadays? Yes. But if they're not going to break down very much because they're not doing anything. They're not doing complex processing. Everything is at the hardware level. So the ASIC chip in this layer 2 switch allows for lightning fast switching, which implies that it's only forwarding on MAC addresses, which is layer 2 information. What happened? The switch people said, well, we want a route. We want to be able to, we want the capacity to forward not only based off of layer 2, we want to forward based off of Layer 3. So a layer 3 switch has come into fruition. And this is the icon for the layer 3 switch. Like this. Why is it like this? I have no idea. This is just the icon for the layer 3 switch. Now you have computer A, and I'm just going to do computer A and computer, well, I'll do C, what the heck. So guess what? Guess what? Now computer A can forward to either computer B or C, not only based on layer 2 information, but also layer 3. Well, how do we know whether or not a switch is layer 2 or layer... And when I say layer 3 switch, I mean that you can program it to forward based on layer 3, but you have to program it. You have to tell it to do that. Because by default, it's simply there as a layer 2 switch. By default. So I'm going to, and then again, there's a couple different layer 3 switches. Now the question everyone might be asking is, okay, how do I know whether it's a layer 3 or layer 2 switch? And first of all, layer 3 switch by default is still a layer 2 switch. But the point is, with a multi-layer switch, you can also configure it to be layer 3. But we'll get to that next time. I'm just saying, you might be asking, how do I know this is a layer 3 or multi-layer switch, aside from the fact that it does say layer 3 switch? Look at the number. We have 3650. So if we look at these end devices, here we have, sorry, I didn't extend the window far enough. My apologies. So here we have routers. Now we have switches right here. We have the 2960. We have 2950, 2950T. And then we have these 3560s and 3650. What switches do you think are multi-layer switches? And don't even answer me. I know you guys are like, well, yeah, 3560 and 36, or 3560 and 3650. And the reason why we know that is because it starts with the number 3. So 3650, number 3 is in layer 3. 2950 or 2960 is in layer 2. And 2950 and 2950 here as in layer 2. So the answer is this. If you are using a 2960 switch, because it begins with a 2, it's layer 2 only. Layer 2 only. If you bring over 3550 or 35 or 3650, okay, that means it's layer 3 capable. It's a multi-layer switch, so it can do layer 3 or layer 2. Now there's a little bit of a difference between the two switches. There's a little bit of difference between these two. If you click on this and you go to the physical, it looks like, on the back of it, it looks just like a layer 2 switch, except you can route with this switch because it is a 3560. So when we configure this, actually to configure it as a router, you go to the command line interface and you go to enable and then conf t. And then you simply do IP routing. That's it. You've turned this layer 2 switch into a router just with one command. IP routing.
Excuse me. So I have a question real quick.
Yes.
So why wouldn't we just use a router? I mean, why use a multi-layer switch?
Okay. That's a great... Man, it sounds like you guys are really listening. That's a great question. Take a look at this. Boom, boom, boom. What did I say what a router is? What is each interface? Each interface in a router is its own network. So look at this router. This is a typical router. Let's take a look at this back. 1, 2, 3, 4, 5, 6. This doesn't count. These two don't, because that's a console. So you would use this to plug in that blue cable to actually control it from a PC. And that's actually, you have to in real life. And then this is aux. So you have 1, 2, 3, 4, 5, 6, and then you have an option to fill these, I guess. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now this, I turn this into a router with this one command, IP routing. And let's look at the physical. That's like 20, 1, 2, 3, 4, 5. That's like 24 ports. Does that answer your question?
Right. So, of course, not all the 24 ports are different networks.
Yeah, they are. If you turn, I've given this entire device the capability of routing with this one command, IP routing. So if you wanted, each of these interfaces could be its own network. But and I didn't want to get into this right now, but you asked me the question. It's a great question. You now have the opportunity to turn each of these interfaces, if you wanted, only if you wanted, into their own network. But right now, they're still switching interfaces because by default, it's a layer 2 switch. So I've given this ability to be a router, but right now, each individual interface is still in switching mode. So in order to hold on just a second. This is a great question. This is kind of like a good tangent. Let's see, show IP interface brief, and there are all
24.
my. Pardon me?
There's 24 fast internet interfaces.
Yes, and right now they're in switching mode. But you can take each individual interface and turn it into a layer 3 interface. So let's go to global configuration mode, and let's take a look at this fast Ethernet 01 interface 0/1, and let's look at how it's set up right now. Let's do it. Do show interface F0/1, and this is the address. The address is the MAC address. Now let's turn this, let's do no switch port. Okay, no, let's do switch, let's reverse that. I'm sorry. Let's do switch port. So let's try to put an IP address. Let's do 192.168.1.1 with a 255. Invalid input. Why is it invalid? Because I told you before that even though I said IP routing, all the individual interfaces are still in switch, are still as a switch. So you do no switch port, and now I can do IP address, and then it takes it. So now it can be identified itself. It can be communicated with on a layer 3 basis for that interface. Okay, so I fear that I've lost some people, but yet the individual person asking me the question, hopefully that person is satisfied. Oh, and you asked, and you asked me, what is the advantage? Well, first off, layer 3 switch has way more ports. Second of all, you can combine in one device certain ports that are routing ports or that accept layer 3, and certain ports are just switched ports. So you literally get the best of both worlds. You can manage entire companies with a layer 3 switch as the basis of it.
Oh, okay, I see.
The proper question is, why are there still routers?
Yeah, that was my question right there.
100%, yeah.
Yeah, why are there still routers? And the answer, ultimately, it comes down to, why is it that we associate, you know, uh, like let's say you walked into a let's say you walked into an eatery, any place that they serve food, and you want pizza, or let's say you want a hamburger. Okay, so you walk into like I'm going to describe an eatery for you. You walk in, there's a guy throwing up, and the menu is disgusting, and the waitress has you could tell the waitress is drunk. Okay, let's and versus walking into another eatery, it's clean, it's the wood, there's real redwood grain on the walls. There's a wine list, a book long, and everywhere there's big bottles of wine. And your server it has a British accent. So, what place do you think is going to be more expensive? The first place with that diner area thing where the waitress is drunk and everything's horrible, or that beautiful place, the second place I described? Which place do you think is going to have more expensive food?
Of course, the second one. So
We say, of course, the second one because we're biased. We're biased. We based on our life experiences. So at one point in time, there was no such thing as switches. There was only routers, and at one point in time, these routers were actually called gateways. Another word for a router is modem, modulating, demodulating. When the switch came out, it was revolutionized the networking place because they did the ASIC switch and applied only to layer 2. Layer 2, those frames on layer 2, the pieces of data that are flowing through are called frames. In layer 3, they're called IP packets or just packets. But man, those frames could just switch like nobody's business. Switching was way faster than routing. But the question is why the routers? Because that's the way it's always been. And the fact of the matter is routers are slower than switches, but people say that routers tend to be more accurate when they route, and switches sometimes can make mistakes. Okay? Now, whether or not that's true, I don't know. What I do know is you're going to have to know both when you get out and work in data centers, when you configure WAN scripts. You're going to have to know both. And that's all I can say. So it is the age-old question, if layer 3 switches are so great, in which they are, why do we even need routers? And the answer is because they're there. And they're here to stay. Because routers do a very good job as well. Okay? So if you have a router in a data center, the problem is to even get access to the router, to even touch the router or any networking device at any data center in America, the amount of meetings that you had, the amount of approvals that you need to even touch a router as an outsider is thousands of dollars. So, it's hard to justify replacing, like if you see an existing Cisco router and it's doing its job and there's no issues, it's hard to justify why you would want to replace a perfectly good working router with a layer 3 switch, because we both know layer 3 switches are probably better, but if the router is doing a good job, it takes so much time and investment and management approvals and meetings and this and that. Like when I was at Stellantis, I was doing data center changes, and to decide what interface to use or decide where to put a server, what rack to put a server, it took months of meetings because they would always argue, I want it to be here, I want it to be there. And then you had to, oh my God, it was just horrible. It was just horrible. But anyways, routers are here to stay because they're there, because they've always been there. Okay? So that's all I can say. Am I jaded? Yes. Am I telling you what you need to know? Unfortunately, yes. All right. So, anyways, looking back here, now the idea here is that default is layer 2 forwarding, 36 and 3650 and 3550 or 3560. Hence layer 3 because of uh, the first number here, and of course 2960 is layer 2 because of the 2. Let me just make this bold. Now the strength of this layer 3 device is its flexibility because you can route and switch in the same device. And let's take a look at the two different switches right here. If we look in the back, this 3560, look in the back, it looks, there's not a lot of diversity at all with this device. Here we have fast Ethernet connections, and I believe these would be gig speed. So this is 100 megabits a second. A gig is 1,000 megabits a second. We take a look. Let's do enable show IP interface brief. And yeah, here's the two gig interfaces right here. Okay, let's take a look at the 3650. Click on it. And let's zoom in. Ooh, wait a second. We got more right here. Okay, let's go over this really quickly. First things first, if you want to use the, and let me get this out of here. Let me get this one out of here. We're going to use that. We're going to examine that later. I actually prefer this one, even though it has less. But anyways, less diversity. But taking a look at this, the problem with this has more diversity. The problem is, in order for even to use it, we need to put in the power supply first. So I'm going to do that. Now, hold on. Before I do that, let me go to the... Now, it's going to yell at me if I go to the command line interface. See? Device must be powered on. That's what we call an HTML or JavaScript alert right there. So it sends this alert, device must be powered on. So in order to do that, see this AC power supply? We drag that over here. Boom. Now it's powered on. See that? Okay. Here we can put in a power cover plate right there. And here, see these are empty. These are empty empty slots. So we can put in a couple different things here. Now let me. So this is layer 2 switch 2960 back. Here's a layer 3 switch. There's more diversity. Now this first slot we can put in, for example. Well, first off, here's what we call GBICs. Here is a GBIC. You slide that in to an Ethernet connection for fiber optic speeds. So you can go to this right here. I'm sorry, the wrong example. You can go back to this. And these you can put in these GBICs in here into this gigabyte slot and connect a fiber optic cable. That's as an example. Now, here you can slide this SFP into into a fiber optic connection, and you can have 1,000 base T Ethernet. Okay, that's what these are. So going back to this, zoom in. So these are empty slots. You can put in your GLC, this GBIC right here. So this allows us to get, here, let me put this in. You can slide it in like this, and this allows us to get 1,000 base T SFP. Okay, this allows us to do it. So we can slide this in here. So it offers us a diversity, if you will, of physical connections. So what is the first thing we should do? Let's go ahead and put IPs on these PCs, but your instructor feels lazy today. So just so you know, this is a layer 3 device, obviously, and this is layer 2, even though it's multi-layer. I haven't really programmed it. And let me get this out of here so this doesn't mess up. But I haven't programmed it. We can look at the show run, enable show run. And if the IP routing command was programmed in, it would be right around here. And I can do that right now. So if I did conf t and I said IP routing and show run, IP routing is right there. But let's go back. And no IP routing. I don't want to mess with that, at least not right now. Okay, so this is layer 2. So I want to configure via DHCP. So what I'm going to do here, I'm going to click on this router, go to command line interface. Now we want to configure DHCP. So we can go to enable configuration terminal, which gets us to the global command line. And what is going on here? Let's see. Okay, your call ends in 15 minutes. Okay, well, we'll try to get done when we can get done. Now let's configure DHCP. Okay, on this outgoing interface. Okay, so IP DHCP. Now, if you're ever not sure where you can proceed from here, the question mark is our friend. And here are the options: excluded addresses, pool, and relay. So we type in pool, and here we have to name the pool of these IP addresses. And we'll just call this the yellow network. Yellow network. So it's asking for a pool name. Yellow network. Enter. Now we can type. Now we're in the set of the commands within the DHCP pool family of commands. We can press question mark again to see what should be next. Next thing we'll do is we'll configure the default router. The default router is the outgoing interface toward the network that we want to DHCP configure. So that is going to be a default router, and it's looking for IP address. So before I do that, let's agree that this IP address should be 192.168.1.0/24. Okay, so this would be .1, just to make things easy. So default router is 192.168.1.1. That will be the IP address of this interface. Enter. Okay, next thing we can do, we set the default router. Let's set up the network name and mask. So network is going to be 192.168.1.0 with a mask of 255.255.255.0. So if you've ever wondered how would your modem know what net IP scheme or IP block you even want to use, and that is how, because you configure it. Okay? And I think that's about it. That's about all we need to do. We can end this, and we can show IP DHCP. Oh, and we can actually ask it to show. And we have one subnet is currently in the pool, current index, and that's our IP address range. Okay, now the next thing we want to do is configure the interface right here. So conf t interface f0/0. We can add a description, LAN int for yellow network. And we can give it an IP address of 192.168.1.1, which is consistent with our DHCP configuration. Okay, and we can verify with a show running config. And we can also verify with a show run interface f0/0. Okay, well, it doesn't do. I apologize. It doesn't do that command in packet tracer, but we do have show interface f00 or show run. I wonder if it does. There's a brief version. No, there's no brief version. Show. Well, we could do show IP interface brief, and then we can have include up, and it shows us all the interfaces that are up, and which includes the 192.168.1.1. Anyways, so we have everything we need here. So now we can go to our individual PCs and go to desktop, go to IP configuration, and go to DHCP requesting IP address, and there we go. It gives us the IPv4 address, subnet mask, default gateway, and it would have given us a DNS server if I would have configured it. Okay, so let's go here, desktop, IP config, DHCP, and the same thing on this right here, desktop, DHCP. Okay, and we could do the same thing on this side too. I'm just going to do one DHCP. All right. I'm just going to do one. If you want to do the rest, let me, if you can go ahead, because I can upload this this topology, and I will be uploading this PowerPoint. Let's look at the default route, how we configure it. So let's continue this. So this is, we're going to do a couple things. We're going to, let's just configure our routing commands. So conf t, and then router rip, and then we'll do network 192.168.1.0. And we have yet to configure the network on this side. Let's give this 200.1.1.0/24. Okay, and let's see. And we'll make this side 192.168.4.0/24 for this side for our local WAN. So this will be our transport link. And to make it more realistic, let's make this a /30. So let's go back to our router right here. So conf t router. Oh, before I do that, let's do interface f4/0, IP address 200.1.1.1 with a 255.255.255.252 IP address. Let's do a no shut, and let's do exit, and let's do router rip, and of course, we have to do 200, and we have to do the class full 200, and so we can do a show run to make sure that our networks are successfully configured under our routing commands. Okay. Unfortunately, time is not our friend right now. So what I want to do is end this and then resend invitations. Hopefully, my apologies. Hopefully, no one minds. So I unfortunately a reality of using Google Meet. So give me a couple minutes and I will resend invitations. Thank you.
Is it only me?
Yeah, apparently, but more people have to join. I mean, I'm sure more people will join. It just takes a second for everyone to log back in.
Yeah, right.
And then every person that logs in, I have to let them in manually. It's just crazy. Okay, we're slowly but surely filing back in, so I'll just wait a couple more minutes. All right, I'm just gonna proceed, okay? And everyone else can just catch up on the recording later. I'm sure some people had to go to work and everything. So let me go ahead and share again. Okay, can everyone see my screen?
I don't see it.
Oh, okay. Let me just stop sharing. And let me try again. Okay, it's not letting me share for some reason. I don't know why it's not letting me share. Hold, let's see. Presentation is start. I want to reload. I hate to do this. I got to reload. 1 second. Shit. Oh man. Okay, everyone here?
You're muted.
Hey, everyone here? Everyone here?
Yes.
Okay, so let me try to share my screen. Allow. Share entire screen. Okay. Can everyone see this chicken drawing right here?
Yep.
Okay. Somebody had asked me about whether to use a single router or double router or whatever. This is actually, and this is what I want to get into. This is actually the usual enterprise topology. So you have here, like, for example, Stellantis might have an Auburn Hills, one of their offices in Auburn Hills. It's just a bunch of offices. There's no manufacturing there. It's just a bunch of the Verizon teams there. The CenturyLink, the transport is there. All the engineers are there, and this area that I'm talking about. So what you have here is a bunch of wireless laptops roaming around, printers, fax machines, coffee machines, but you have all these people around here. So this is like, the LAN. This is the network edge. And then the network edge ultimately links to a router that's could be directing traffic to their local data store, their data center. And then the other end, you have this router that is responsible for sending it to the internet. Okay, so what the routing actual configuration is that you will configure the one route to the data center, and you'll configure another route to the big I internet. But there's another concept that I wanted to talk to everyone about before we went into layer two switching directly. Before we focus on layer two switching on next Tuesday, and that is the idea of the default route. That's exactly what I wanted to talk about. So what we're going to do is replicate that here. So I did the show here. Let me do a show run, and we can see that there's our DHCP configuration, and here's our router information here. Now let me do the same thing for here. In this router right here. I'm just gonna be lazy right now. I'm gonna go to FA00. We're gonna call that on. IP is 192.168.4.1 with a 255.255.0 IP address, and this is this is a loopback, so I can't configure from there. Let me go to end, and let me be safe. Let me do no IP domain lookup to make sure I don't make any mistakes. And then here we have interface loopback 1. It could be loopback 0. It could be loopback anything. IP address 8.8.8.8 with a 255.255.255.0 IP address. Let me go to exit, and then let me do router rip, and then we're going to do the classful network for this, which is it's a class A, so it's going to be 8.0.0, and then here network 192.168.4.0 net 192.168.4.0, and that should be it for this. Now from this we should have a route to this server network. So show IP route, and no route to that. And actually, let me configure the IP addresses. We're just going to do this statically. Just so you know, whenever you have a server, even a print server or data server or anything, never allow it to be configured via DHCP. You always want to put a static IP address, so 192.168.4.2, and let's give it the default gateway of 192.168.4.1. Okay, good. Now here, see what's going on here. Let's do a show IP route on this side, and there's no network that was learned via RIP either. Let's see what's going on. I mean, I'm sure it's a problem with your instructor's configuration. So let's do show running config, and IP address 8888. Let's see. That's correct. That looks correct. FA00. That looks correct. Let's look at the RIP commands. That looks good. Let's take a look at this one again. Show running configuration. Let's see. So FA00 1.1. Oh, did I do? Let's see. Serial fast Ethernet 1. Let's see. 40. Wait a second. Let me go back to this. I might not have done something right. Aha! That's what I didn't do. So I didn't put an IP address on FA400, and I didn't route. I didn't put in this information. Here, let me just see. I put it in this side. I know I did. 40. I didn't put it on this side. That's what the problem is. So conf t interface f4/0, no shutdown, IP address 200.1.1.2 with a 255.255.252 subnet mask. And now the other thing I didn't do is I didn't route the network, because if you do show run including router rip, well, network. Okay, so here are the network commands I put in: 8.0.0.0 and then 192.168.4.0, but I didn't put this in, so let me do that. Comp t router rip network 200.1.1.0 end. Okay. Now let's do a show IP route to see if anything changed. Aha! We do have that routed. We do have RIP configured. It detected the remote network. Let's see what we got on this side. Show IP route. Aha! We have detected two remote networks through RIP. 8.0.0 and 192.168.4.0 network. So here's a computer that I know that we configured our IP on. Let's first ping the default gateway of this network, which is 192.168.1.1, and it pings. Let's go ahead and ping this other side, which would have been 200.1.1.1. So ping 200.1.1.1, and it pings. Let's ping right over here. That's .2. It pings. And finally, let's ping this side. This, which is 192.168.4.2. 192.168.4.2. Let's see if it pings. It's probably, I should have pinged I should have pinged 4.1 first, but that pings. Okay, so we're set. Now the internet, going back to this, does everyone understand why the capital I internet would be the default route? Because what the default route says is that anything that doesn't match, like if this PC wanted, like if this is the network printer, okay, we'll just draw a circle around here. If this PC wants to get to this network printer, okay, it's not even going to use routing. It's just going to connect to them via layer 2, which is the MAC address. If it wants to go out to the data center, it's going to go out to this router, and it's going to make a request, which way do I go to get to the data center network, and it's going to know to send it this way because of routing commands. Now, is it going to know how to get to Facebook? Yes or no? And the answer is no. Is it going to know how to get to Amazon? The answer is no. So you have to have something called a default route. A default route is the route that the router goes to in the instance that it doesn't know how to get to any known network. So it knows to get out to the default route. So the question is, how do you configure a default route? So on this, which would be the default route? The default route will be towards the internet. So to configure the default route, you simply do this. Here on the local modem, you go configuration terminal, and here you actually, it's like you're configuring a static route. You use IP route, okay? And you know what? Also, if you want to make sure that if your RIP route fails, you can still get out to the internet. You may not get to the database, but you can get out to the internet. You say IP route 8.8.8 or 8. Oh, I'm sorry, 8.0.0 because you can use classful. And to get to the destination mask, well, you can do, let's just do 0. I'm sorry, 8000. And let's do you know what? Let's not do that. Let's just do this. Let's do 000 any, and that is out F4/0. So a default route is a route with any destination address, any subnet mask, you go out F40. Okay? Now, if we go to end and do show IP route, our routing table now has this thing called gateway of last resort is 000 set to network 000. That star means it is the what we call the default route. That's the star right there. Now, what's the benefit of the default route? Well, the benefit is this. Let's say let's see if we can ping 8.8.8 and we can get out to the internet. That's what 888 represents in this drawing. We can get out onto the internet. Now let's say for example, we get here, and because we have a default route, let's say something happens to our RIP right here. So let's say, for example, configuration no router RIP. No router RIP. Now let's go to show IP route. Okay. Now the RIP routes are gone, but this default route still is here. Okay. So let's see. Let's try to again ping 888. And it still pings. And let's try to ping 192.168.4.1, for example. Okay. Now the default route is there in case our existing route has been disrupted. Okay, so we know it's a default route because it has this asterisk next to it, and it says gateway of last resort is configured to network 000. So that is the default route. Okay, that's what I wanted to explain to everyone. Now let's take a look at this command show IP protocols. Okay, because show IP protocol shows the ripping protocols. That shows the dynamic routing protocols if there are any. And right now there are none. So let's do configuration terminal router RIP And then let's go ahead and we're going to do the entirety of all of our networks because there's 3 networks and I'm too lazy. So if we did show IP route, okay, again, there's no, it may not understand, oh, it may take a second for it to populate. Okay, it does not like that. So let's do router rip and then let's do network, let's do no network 000 and let's do network 8.0.0 network 200.1.1.0 and network 192.168.4.0. Okay, now we have our RIP routes back, so we can do show IP protocols. Now here's interesting. So this is RIP, and we have distances 120, and we're else distributing RIP send version 1. Okay, let's see. The next sending updates every 30 seconds. The next one is due in 22 seconds. Okay, and let's see what else. Passive interfaces, routing information sources, and so on. Sending updates. Okay, but here's the problem. Now let's say we wanted. Now we can actually also configure version 2. So we can do router rip version 2 end, and if we did show IP protocols, now it says send version 2, receive version 2. So that's how we know. That's how we know whether or not we're sending version 1 or version 2. The show IP protocols tells us more details, and it shows us all the networks that it's routing. Okay, in case you wanted to find out if, for example, there was an issue. So let's say we did interface loopback 1. Did I do? Oh, is that 1 or here? Let me just see something. End. Let's do a show run. Let's see, or actually, let's do a show IP interface brief, and let's see, loopback 1. Okay, and we have let's see, local. Oh, I'm on the local modem. I'm sorry, that's what I was. Okay, that's what was going on. Anyways, so that's the default route right there. Okay, that's the default route. Meaning that if if your dynamic routing protocols have been disrupted, the default route is still there and it can still lead you outside to the appropriate router. Okay. Layer 2 issues for local area networks. So Ethernet is basically CSMA CD, carrier sense multiple access collision detection. Okay, now wireless is CSMA CA. The A, whereas CSMA Ethernet is CD, wireless is CA. Everything else is the same. So collision detection means that it detects a collision. Collision CA means CA equals avoidance. So wireless tries to avoid collisions. And Ethernet is 802.3. That's the IEEE standard. And wireless is IEEE 802.11. So with detection, we all know the CSMA CD algorithm. That when you have PCs connected on the same line, to try to detect collisions, it listens first, and then if it doesn't see anything, hear anything, it will send. Now there is a collision, but there's a way to, there's a recovery system with those collisions, but it can be slow. If you have, let's see what's going on here. Yes, it is. Yes. So if you have a collision, CSMACD is a recovery option, but it's slow. If you have too many collisions, it can add, fragmentation. It can add latency. So with wireless, you try to avoid collision because unfortunately you do not have listening available on wireless because they really don't communicate to each other. So if you have like laptops sending a wireless signal, what they're doing is they're communicating with their, access point. We'll call it AP here. They could, they're connecting with the AP, and they don't really connect to each other. So here we have two laptops here, and they're connecting, but they don't connect to each other. They connect through the access point. So you don't really have the ability to detect, like, they don't have collision sense. They don't have that like the Ethernet does, like a wired connection does. So you want to avoid any type of collisions. Okay, now let's take a look at Ethernet issues, span tree protocol. Okay, with span tree protocol, you actually have switches. Well, here, let me just show you. So with span tree protocol, you can have various switches connected to each other. All right, and span tree protocol says that there is one way and one way only to get to the edge of the network. So here you have switches, and you might have a router that connects everyone to the edge of the network, and these are all connected to each other. So the question is, how do these switches determine the one singular path to get to this router? And it uses kind of like an election type thing, and we'll get to that more next week when we talk about when we go dive back into layer 2. But it helps define a singular path from point A to point B. So how do you navigate? And there's an election that occurs that is similar to a political election, and we will get to we will talk more in detail about that next week. But I just wanted to introduce to you the concept of span tree protocols. The one I really want, the layer 2 issue I really want to talk about is something called VLANs. So a VLAN is a LAN built inside of a network. Okay, and you know what? It is 12:30, and I probably should get going because the class is basically over with in terms of time. So I'm just going to end it here. I will upload this PowerPoint to our course shell today, and I will upload the recording. Okay, everyone have a good day. I apologize for going over.
Thank you.
You too. Have a wonderful day.
All right.